Well, hello there, and welcome to another episode of the making of Pokemon Gemini. So, in the last episode, we started all of the wild encounter code, and by that I mean we added the tiles that triggered wild encounters, like single battle grass and stuff like that. Now we actually get to start working on the battle. But in order to code a battle between two Pokemon, we need to actually have some way to store the properties of the Pokemon. So I did a bit of that off camera. So we saw during the episode where we did all of the sort of region files that define the properties of regions, we saw how JSON works and stuff like that. And so I just went ahead and off camera created these files. So if we look, they're under our data folder, under monsters, and then one file for each of these monsters. I hesitate to call them Pokemon because they're fake Pokemon. And in the final game, I'm now debating whether the first version should be considered Pokemon or just its own thing that's inspired by Pokemon. I haven't decided yet. For now, I'm going to continue calling it a Pokemon game until the final version. But um, but yeah, so these are monsters, Pokemon, monsters, creatures, whatever you want to call them. So they're stored in the data monsters folder. And again, one file for each one. MDF, just I made it up. Call it monster definition file or something like that. But yeah, all it is this JSON that we've come to love with our region files, but defining things about the Pokemon. So with the art that we have here, let's view some icons here, extra large icons. So we have a couple of Pokemon that Zach here made. So we have Mautide and Wetatide, and so I've created those here. And we have Schnauzau and Merrill, and those are over here. And so for now, just to make sure everything works, I'm only going to be working with these guys. And then as everything comes together and starts working, we're going to just start defining more and more creatures, more Pokemon. And the numbers here are very like general ballpark numbers, and those will be calibrated again as the game progresses. But now we're just focusing on making things work and be functional. So the format that I have here is you have the name of the Pokemon, the catch rate, which is going to be how easy they are to catch, a higher number being easier to catch, a list of things they can evolve to. In this case, they only evolve, each of these only evolves to one thing, and then the higher evolutions don't evolve to anything, so it's an empty list. And the reason it's a list is because we have Pokemon that can evolve into multiple things. For instance, the classic Eevee, so we might have Pokemon that do the same. And then each of these evolution lists is an object that has a type and then some other values. So most evolutions are going to be of type level, meaning they evolve at a certain level, which then says what they evolve to and the level that they evolve. There might be other types. So for instance, we might have type item use, and then we might say the item is, I don't know, in this case it's a dark type, so dusk stone, something like that. And then to Super Meryl. Obviously that's not a thing, but you see the point. By doing it this way as an object, we can have different types of evolutions, which can be very useful. We might even have the ability later, if we need to have, say, in a level up, we might have conditions, and then like has item dusk ball or something, and we'll say if they hit level 28 and they're holding a dusk ball, then they evolve, or something like that. Obviously these are examples, but the point is that by setting them up as objects, we can have all these sorts of conditions and different types of situations that cause them to evolve. And by having it as a list, we can have them evolve into multiple things, branched evolutions, which is pretty cool. Evolves from is going to be a single thing, because even though one Pokemon can evolve into many, each Pokemon can only evolve from one thing, right? So you can have a whole bunch of different evolutions of Eevee, but they all evolve just from Eevee. And that's kind of how all Pokemon work, and I think that's the way this is going to work as well, because having different Pokemon evolve into the same Pokemon is kind of weird. I might change that later to a list if we need to, but I don't think I'm going to need to. The only reason we have the evolves from, for instance, in Meryl we have evolves from Schnazal, is so that we can trace the evolutions backwards and find evolutionary families in the code. So the code can grab a Meryl, and then it can say, oh, it evolves from Schnazal, and then load up Schnazal's data, and then say, oh, it could evolve into other things, right? And so this way we can, compile a list of the entire evolutionary tree in the code if we need to. So it's basically a doubly linked list, if you know what that means. And then we've got types, which in this case is just normal, but it's an array because some can have two types. So normal and dark, for instance. Maotide is just bug, and it evolves into Wetitide, which is also just bug. But yeah, it can have multiple types, like the Meryl here. Then we've got the description for the Pokedex, or whatever that turns out to be called if it doesn't become a Pokemon game. And then we've got in the description, so each game in Pokemon has a different description for each Pokemon. So I want to do the same thing here. So we have the Castor and Pollux kind of paired games, and I want each one to have a slightly different description. So I'm going to put that in here, and then based on what the game is, we can just look up the right description for the game. But the actual files will have data for both games. So that's how that's going to work. Whereas encounters are going to change per game, and that's going to actually be entirely different region files for each game. Because I think it'll be hard to do kind of both types of encounters for each terrain type in each region. It would get messy that way. So I think for encounters that change by game, we're just going to have separate files for each game. But yeah, then we have the base stats, and again, these are just numbers I picked based very loosely on Rattata and Raticate, just to pick some numbers. EVs, which are what you get that boost your stats based on what you've defeated. And then, so for instance, defeating a Schnazal helps boost your speed. That's how the Pokemon games work, so I just went with it. And then a list of moves that are learned. So originally I was going to have the moves be an array, and have the array be a list of objects, each with a name and then a level that it's learned at. But I realized that there's no point in having a list of objects with a name property when I can just have an object and the key and the keys are actually the name of the move, and then the value can be the level it's learned at. Now there are 3 ways that a Pokemon, well, I guess 4. Well, yeah. So there are 3 real main ways that a Pokemon can learn a move, and that's if they level up to a certain level, if they evolve, because in the newest version of Pokemon, as soon as a Pokemon evolves, some Pokemon just learn a move just by evolving no matter what level they're at. So that's an option. And then also, there's the TMs, HMs, whatever I'm going to call it in this game, ways that you can find moves and teach it to them. There's also the move tutor, but all that does is teach them moves that they knew that they could have learned in previous evolutions and previous levels, so that's nothing. So what I figured is all of these move values would be a number, and if it's a positive number, then it would be the level that it learns it at. So in this case, it learns bite and scratch at level 1, it learns pound at level 5, etc. But then we could set it to 0 if it's supposed to learn it as soon as it's generated, or in the case of an evolution, as soon as it evolves. So if I did, well, in this case, this is a stage 1, but if we have a stage 2 evolution and we say, oh, it learns Body Slam at level 10, well, if we say it learns Body Slam at level 0, then that means as soon as Schnazal, over here, evolves into Meryl, it automatically learns Body Slam no matter what level it's at. So by having level 0, which is not an actual level, we can use that as a special value to indicate that it learns that as soon as it evolves. And then we can set it to -1 to to say that it never learns it at any level. It just learns it. It just learns it by TM, HM, whatever, right? So this way, if it's on the list, it can be learned. If it's not on the list, it can't be learned. But if it's on the list with a negative value, it can't be learned at any level. It can only be learned by teaching it with a TM or whatever, right? So by using this kind of format here with it being an object, we are able to encode all the possible ways that a Pokemon can learn a move into this one value, which is, I think, a good idea. Makes things simple. Okay, and so once I created these four, I changed the grass encounters for Route 1, where we've been testing, from Pidgey and Rattata, over to Schnazelle and Mautide. Still level 3 and 2 and the same chances and everything. I haven't changed any of the others because I haven't actually added any other Fakemon in, but for now, where we're testing are these, is the grass encounters of Route 1. So what we can do now is actually get to coding stuff. Well, first I am going to want to, as always, import our data back in because we've changed our data. So send to zip, delete the old data, and then add in the new data file. So data does it. Okay, so now we should have the new file. So now we need to actually load in our Pokemon data, or our monster data. So I'm going to use something similar to our init data. So that's going to unzip it, but we don't actually have like a list of Pokemon. We don't need it for the regions because when you enter a new region, you already know what the region is and you can look it up by file name. But with the Pokemon, it would be much better rather than having a, when you need a Pokemon of a certain type, how do you know what possible Pokemon to choose from, right? And obviously there's the encounters, but then there's other ways, and basically it'll be easier if we have a list of all the Pokemon data in memory, or a map. So we are going to load that in. So we're going to have init, let's call it monsters. Again, this may end up not being a Pokemon game, so I'm going to try to avoid the word Pokemon in places that it doesn't need to be. So, yeah. So init monsters takes no things. And so what we want to do, we want to make this as versatile as possible. And so I kind of want to have it just scan the directory. So this is in, these are all in data/monsters. So I just wanted to scan that monsters directory for any and all files that end in .mdf, monster definition file, and load them all in. And use the file names as the name of the Pokemon or monster. And by doing that, it'll make it a lot easier to add and change and manipulate all the Pokemon data, because I can just go in there, add a new file with its own data, and it'll automatically get loaded in the next time you run the game, right? Or the next time it's imported and run. And I don't have to worry about changing any code. So let's start doing that. So the first thing we need to do is have a variable that will hold the name of the file. And then we need contents, because we're going to be reading some file contents. The file itself that will be opened and closed and modified. Okay. So let's just start with that. So how do we find the file? So the first thing we can do is file find first, and it's under data/monsters/star.mdf, right? And we'll just use normal files, which apparently is not a thing, so I think you can just use 0 for normal files. So what this is saying is it's going to find the first file that matches this pattern. So it's in data/monsters and ends in .mdf. And that should give us the first file name. and then I think it returns an empty string if it can't find anything. But let's just try file find first. Function will return the name of the first file that satisfies it. Yeah, if no such file exists, an empty string is returned, right? And so by doing that, we just say while the file name is not an empty string, in other words, as long as it found something, we can start reading some contents in. So we will have contents equals nothing, file equals file text open read. And the question is, does it contain the path or just the file name? In other words, do we have to write it ourselves? Oh, that doesn't really help. It doesn't say whether the thing contains the entire path, like data monsters, or if it's just the file name. So actually, before we do that, I want to just do some debugging just to see what the actual output is. Show message fn, and then fn equals file find next, so that we can find the next file. And it's going to just use the same pattern from the file find first that we ran. And then we can do file find close to stop the search. And so by doing this, now if we run init monsters, we should, init monsters after init data, because that's where it actually unzips everything. And we should be able to see whether it contains the full path or not, and then we'll know whether we need to add it or not. So we have our managers. I think our region manager is, no. Where did we actually call? I think it might be in our resource loader. That sounds about right. Yep, init data. So now we'll do init monsters. So after we've initialized the data by unzipping it, we're going to load in all the monsters. And right now, it should just pop up some file names, and we'll see whether it's just the file name or the entire path. And that'll let us know whether we need to specify the path when we open the file or not. Wait a second now, once it compiles. Okay, so it's just mayoril.mdf, mayotai.mdf, okay, so it's just the file names and not the full paths, so we need to prepend the path ourselves, which is perfectly fine. So we have file text open for reading, data monsters plus file name. So that'll give us, that'll open up the file, and then just to make sure that we don't forget to do this later, file text close file, and then we read the file. So while we are not at the end of file, EOF, we will, we set contents plus equals file text read string from the file, and then file text read the next line. And I don't remember if we had to add the line break, so let's just, that's not going to, over regions. So when we loaded it in here, we did not load the slash, so we don't need to, or sorry, the new line. So we don't need to do that. That'll be included. So this will give us the contents. But all this is going to do is overwrite the contents each time when we find a new file. We need some sort of kind of global map of all of the Pokemon that we've loaded in. So I think I'm going to load all of this into a monster. So once we've finished reading the file, we will load the contents as a map, which is just, JSON decoding. And we can then put that into a global map. So we'll say monster equals JSON decode contents. And then, as we found out in the last episode, except this is not, it probably won't add the default key like it did with the regions, because unlike the regions being a list, this starts out as an object, so it'll probably allow it to just be a map. And so now we just have to add it to some kind of global storage that keeps track of all of our Pokemon. Now there are a couple of ways I could do this. I could just have one big map that maps the Pokemon name, which we know from the file name here, also with the name. It maps the Pokemon name to its data. But what I actually want to do is have two separate structures. I want to have a list of all the monsters, and then a map that maps the name to their index in the list. And I'll explain why in a second, but first I'm going to do that. So we'll have global monster list equals, I think I want where is it? Resource loader at the game start. Before it loads all of this stuff, I want it to have a global monster list and then global monster map. Okay? And then we're going to start adding our monsters to that list and map. And the way we're going to do that is we're going to go ds list add global monster list, and we're going to add our monster to it. And actually, we want to say add map. Sorry. That's for a map. So now we have to ds list mark as map global monster list, ds list size global monster list -1. So what this is doing is when you call JSON decode and JSON encode, and also when you destroy a map or a list, any maps or lists that are kind of nested in it, so like if you have, in this case, we have a list, but we're putting a map inside the list, it's not actually going to put the whole list inside. What it's going to do, or in this case, the map is not going to be inside the list. What it's going to do is it's going to create a handle, which is just a number that refers back to that map, and it's just going to put the number there. So if you don't mark this as a map, the game later won't know that this is actually a map, and so it's not going to decode it right or encode it right with JSON. And if you delete the overall list, it's not going to delete that map because it's not going to know it's a map. Whereas if you mark it like this, then it'll encode properly because it'll say, oh, I know it's a map, and so it'll go to the map that it references and actually encode that. And also when you delete the list, it's actually going to go through and say, oh, this is a map, I better delete that map too, and it'll go and delete the map. So JSON decode automatically does that marking for you, but in this case we're adding it ourselves to a list, so we want to mark it manually, just to make sure that everything is marked correctly and we can delete and encode everything pretty quickly without having to manually go through it and delete their maps ourselves. Hope that made sense, but point is this is mostly for maintenance. So we mark it, but now it's there, it's in our list. So now we want that map. So we have what we can do is we can reuse our monster variable because it's going to be reused every time this loads a new thing anyway, and we already have our monster data stored in that list. So we can reuse our monster variable and use it to store the monster name. Although actually that's not good practice, so let's just have a monster name here. So the monster name will be the file name change extension of the file name to nothing. So what we're doing here is the file name will be something like mayrel.mdf. By using file name change extension, and changing the extension to nothing, we're replacing the .mdf with nothing. And so we're getting rid of the extension and leaving just the file name. And yeah, so that should leave us with our Pokemon's name. And so now we can go global monster map, monster name equals, ds list size global monster list -1, which is the last entry in our monster list, which would be the monster data we just loaded. Okay, so why did I do it this way? Why didn't I just put the monster directly into this map? And the answer is this will make randomization easier later. So a common way that people play the Pokemon games is to randomize everything. And by that I mean change which Pokemon appear where, which Pokemon are in which people's parties, stuff like that. You know, the trainers that you thought had like a Pidgey, now all of a sudden they've got, I don't know, a Giratina or something, right? And that's fun because once you play through a game once, if you already know, where all the Pokemon are, so you know on Route 1 there's only going to be, in this case, on Route 1 there's only going to be Schnazelle and Mowtide, and you know that, then it gets a little boring. But if you randomize it, then all of a sudden there could be anything on that route, and it gets a lot more interesting when you don't know what you're going to see next. And so I want eventually to add support for a randomized mode. And by splitting things up into a list and a map like this, it becomes extremely easy to do that, because you have your monster map, and it's linked to the data in the list only based on the position in the list. So if at some point later, like when you choose the random option, we were to do ds list shuffle global monster list, now all of a sudden the monster names are going to be linked to completely different data in the monster list, and so we've just automatically randomized everything with a single line of code, right? So that makes things a lot easier. It does become a little bit harder with trying to keep evolutionary lines intact, because, for instance, this says that Schnazelle evolves into Mayrail, but if it looks up Mayrail on the list, once it's randomized, it's actually going to be a different entry. We can deal with that later. It shouldn't be too hard. We should be able to have just a secondary list that takes the name from the file instead of being shuffled. So it should be pretty easy. But we're not going to worry about that now. Just know that that is why I'm having it done like this, with a separate list and then a map on top of the list, instead of just directly putting the data in the map. But for now, we aren't shuffling anything, so we should have all of our data here. So now what we can do, we have our terrain manager, and we have it get encounter. And so what we can do, instead of returning the actual encounter, we can look up, well, the encounter data has a name and some other stuff. So where did we actually handle that? I think we did that in the player, down here somewhere. Right. So we have the encounter species. So rather than doing that, what we could do is the region manager, when it returns an encounter, well, I guess I could do it in the terrain manager like I was going to. So when we get an encounter, we will encounter species. We're going to replace the species with the data from, okay, so ds map replace I don't want to do this. No, I think I could just do it this way. So encounter species equals, and then we just do global monster map encounter species. So we do that, and that should work. It should replace the species with the data of that species from the monster map. Now I was going to add it and mark it as a list, but I don't think we want to do that, because if we delete the encounter map, we don't actually want to then delete the data in our actual global list, because that would ruin our database. So we want to leave this one as not marked, and so it won't copy it over, and it won't delete it and all that. It'll just be a handle. So this should work. So now in our player, we have the code here, which just draw encounter is the species, but instead, now the species should be one of these. So we'll take the species name. So equals encounter, sorry, equals draw encounter name. So this should take the name of the species based on what was loaded from the actual data files. So yeah. So now in the grass, we should only get the two fake mon, the Schnauzau and the Mautide. Okay, and hopefully it doesn't crash. So let's move around in here until we encounter something. Undefined. Well, isn't that a problem? Okay, so it said undefined, which unfortunately means it is not getting our data. And so what I can do, I can see, first of all, whether that data is not loading in properly. And if it's loading in properly, then the encounter is not getting it properly. It's not looking it up properly. So let's see if it's because of this. So if we do show message JSON encode global monster list. Oh, wait. Global monster map. Did I use monster map or did I use monster list over here in the terrain manager? Global monster. No, I used monster map. Okay. So let's check out the monster list. And then, actually, did I add it as a map? I did. But I didn't here. But that's just an index, so that's fine. So the monster map, excuse me, should contain a map of names to just indexes, which are numbers. And then the monster list should contain the actual Pokemon data. So set speed. What? Stop sound, fade into mute. There we go. Weditide, Mautide, Meryl. Cute. What? The hell? Schnauzau. Play music. So Weditide is 3. Meryl is 0. Mautide is 1. Weditide is 3. Schnauzau is 2. So those are correct. But why is it getting all of these methods? All of these methods from what looks like our music manager. That's weird. That's very weird. So this list is not global monster list, global monster map. Global monster list, global monster map. And our resource loader creates global monster list and global monster map. Oh, that'd be why. Because we created the map as a list instead, which means the index of the list was trying to be used to access a map, and that index happened to reference a map that was the methods of our other thing. So, nope, Still not working? Well, that worked. But, okay, so we got one thing fixed. The global monster list, which according to our resource loader, global monster list is a list that is created up here. So then why? Why would it end up being what looks like the music manager's method map? Or does JSON encode not work with lists? Does JSON encode always expect a map? That might be why. It might just be an issue with our display. JSON encode. Yes, okay. So it only works with a map. Not a, okay, so it's expecting a map. So it's a similar kind of issue, but that's just in our display. Whereas now that I've set that to a map instead of a list, it should at least work correctly in the actual encounters. We just won't be able to display it without sticking it in a map first. No such luck. And just keep moving around here till we get an encounter. Undefined, still undefined. All right, but we saw that the map looked right. So what we can do is temp and create a little map, and then we say ds map add list temp list global monster list. So by doing it this way, we can then destroy the, oh, we don't want to. That's going to be a problem. Well, I'll leave that in, but I'm just going to have it show the JSON encoding of our temporary map. This way we should be able to see list and then actually see the list of Pokemon data or monster data and see what's actually being stored in the list. Okay, so we have name, Mariel, EVs. It looks like it's all correct. This is all the data that I typed. So each one in the list. Okay. So, all right, so then if I do JSON encode global monster map, or you know what, let's do it in the encounter code. So when we get an encounter, we'll do show message encountered species. So this will tell us what was the name of the thing we encountered. And now we should be able to go like this and then say show message data is a JSON encoding of the encounter species. Right, so this should tell us, originally it'll tell us what the actual name is, and then when we convert that name to the data in the map, we should actually see what data it's pointing to. And so maybe it's just not associating properly, even though it looks like it is. So let's get an encounter here. Encountered Maotide. Okay. And that's a problem. Oh, am I adding it as a list? marked as a map. No. It's a map, right? Oh, duh. Okay, so this is giving us the index in the global monster list. It's not actually giving us the direct data, so we can't look it up directly. What we need to do is, so that's going to be a number, and that's going to be the index in the monster map, so or in the monster list. So instead, we need to do encounter species equals global monster list encounter species, because and the reason we're saying encounter species a lot is just because we're replacing that one variable, right? So we have encounter species, which is just going to be the name of the species, and then we're going to replace that with the lookup from the map, which will be an index on the list. So then we replace it again with the value at that index on the list. So now, if all goes well, I should be able to get data. Okay. No such luck. Let's get some encounters. Undefined still. Why is it still undefined? You know, I really thought that'd do it. Okay, so that should be a map, so we should be able to show the message with the JSON encoding of encounter species. So what I want to do first, I want to do a few different bits of output here. First, I want to say what I encountered, right? I'm going to say what I encountered. Then, once we've gotten the index, we can say, ooh, why is this all messed up here? We can say index, and then once we've gotten a map, we can say map data and encode that. So what we should get when we encounter something is a pop-up with the name of the thing we encountered, then its index on the list, and then the actual data that it reads from that list. And we know from the init monsters debugging that it definitely is loading in right. So we're just not reading it right for some reason. So let's see where the reading has gone wrong. Okay, encountered Mautide, index 1. Okay. Map data, name, Mautide. Okay. So, but it still says no such luck because, oh, and we have an error. Do add execution error. That doesn't tell me what's actually happening at all. But let's see. Encounter species. Somehow, there's an execution error here. Why? It worked the first time, but then it broke. Okay. This is under Terrain Manager, Event 1.1, line 24. The second time it breaks, Event 1.1, line 24, which is here. Huh. Unless, are we replacing the original? Oh, you know what's happening is we're actually modifying the original map when we do this, which is not good. So what I want to do is I want the encounter to not be an encounter list. I want it to be a copy of it. Now there is a function called dsMapCopy, but if you do that, it makes a shallow copy of the list, which means it won't copy any like lists that are inside of it. It'll only copy the handle to them. We need to copy all the data. So I think what we need to do is we can make a deep copy by abusing the JSON encoding. So let's say var, well, I don't want to do that. So encounter equals ds. So JSON decode, JSON encode. So if we do this, I think it'll make a copy and then so then after we break, we can go dsMap destroy encounter. So what that should do is make us a deep copy of the list, and then if we end up not encountering it, then we just destroy it. But if we do encounter it, then we should be modifying the copy of the list here instead of the actual list in the encounter data, so we aren't corrupting our data for the next encounter, which I think is what I was doing. So hopefully this won't crash, and if we're lucky, it'll even work. Encountered Maurtide, index 1, but we didn't actually encounter it. Encountered Maurtide, index 1. Okay, but it's not crashing, which is good. But every single time, it's saying we encountered Maurtide. So that's a thing. Okay, but I'm going to get rid of that debug output because it looks correct. So then we can wait around until we actually technically encounter it, because it generates an encounter and then decides whether you've encountered it or not. So let's get rid of let's comment out our debug in case we need it later, so that it won't pop up anymore. And now we can walk around freely without it popping up, and hopefully without it crashing. And we should be able to test whether it worked or not. And if we just keep moving around here, we should ultimately actually have a successful encounter rather than just, there it is. It said Maurtide. Did you see that? I saw it before I moved. So it looks like it worked. It said Maurtide this time, which means we should now have Schnauzau. There we go. So it got Maurtide and Schnauzau. And so if we wanted to, we could get other information about it, like, for instance, its type. So type's 0. So if we, and then in our region, we also gave it a level, right? Level and chance. We don't need the chance, because that's already used to determine whether we've encountered it or not. But we can get the level. So that's the draw encounter is the name. And then we have draw encounter plus equals that, which is a new line in GameMaker. Don't ask me why they went with that symbol, but they did. And then so actually let's do var species. That way we can reference it over here. Then we can say species, yep, so this is going to be the types, which is species, actually, var types equals species type, or types. Did I call it types with an S or not? I did, so types. So now we can say species, so we could say types 0, which is its first type, its primary type, and then a new line, and then below that, level string, encounter level. So basically, I'm just drawing more information about it than just the name. So this will allow us to know whether we can actually look up information about the species that we've encountered after encountering one, along with its encounter data like its level and stuff like that. And hopefully we should. I've just got to get an encounter, and then we'll know. And we get an error. Encounters. Oh no, I put an S on it, didn't I? That's my fault. That's just a typo. Because it's called encounter, not encounters. So that is my fault. No big deal. Just a simple typo. Only big deal is now we have to wait for it to recompile and search around for an encounter again. So hopefully it should pop up soon. There it is. Oh, I just saw bug level 2, but I assume that was Wetatide? Or Mautide, I guess. But I missed it, unfortunately. Schnauzau level 3. Okay, normal. Okay, so it got all the data about the Pokemon. We're good. So what this means is that when we encounter something, we can get all of the data about the encounter. And actually what we want to do here, once we have the data about the encounter, so do other encountery things, and then once done with the encounter map, we want to destroy it. Because remember, this encounter map was a copy of the main map. And we don't want to just keep copies around every time you encounter something because they're just going to add up in memory and start leaking. So we want to destroy it when we're done with it. And since it was created with JSON encode and decode, all the nested maps and lists are going to be destroyed just fine with that. So that's good. Now it is 52 minutes in, so I don't want to do much more than this today. But this is the basics of the battles because now we have a format that we're using to store all of our Pokemon data in. It's getting loaded in to the game into some global list and a global map associated with that list so that we can randomize it easily later on. But for now, it's just associating names with Pokemon data. And then every time we encounter something, we can grab that Pokemon data from, based upon the encounter data in our region file. So whatever's here, that name will be, matching a file name in our monsters thing, which will contain all the data about that Pokemon, which the battle system can then load in later. And we know it can because we've loaded in types, right? So we've loaded data from this, monster definition file in our encounter code. So we know we can do that now. So our battle system can load whatever it needs to. So yeah, and it's got all the base stats, so it can take the base stats and then the level from the encounter, which we know we can also grab, and start calculating what its actual stats will be, etc., etc. But that will be for another day because this is a 53-minute episode and I don't want to get to an hour and a half like the last episode. Point is, we are on our way to making battles work. I know this may not have been the exciting, let's bring all our sprites in and start a battle episode that we wanted, but it is necessary for battles to work because before this we didn't actually have any Pokemon data for the battles to use, and now we do. So yeah, so next episode, hopefully, as far as I can tell, should be the actual battle room where we'll have objects to represent the Pokemon based on their data from the map, because now we can just look that up. Nope, sorry. Now we can just look that up from this. We can say, okay, what's the name of the Pokemon? Okay, look it up, get the data from the map about it. We know from the encounter list, its individual level and stuff, and then we can start calculating all of its stats. The sprites are going to be based on name. So the name, for instance, so the name Schnauzau, for instance, there will be a sprite in our here where we have our Nagon, which will no longer exist as of the next episode. By the end of the next episode, that'll be gone. And we'll have our custom sprites in from Zach. Thank you, Zach. So we'll have like Schnauzau front and Schnauzau back, or we'll just have a Schnauzau sprite and have the 2 frames be the front and back, which is probably what we're going to do since they're not animated. So that'll make it easier. And then we can just load it from there because we have this nice little function called asset_getIndex, where we pass it a name and then we get the index. So we can just pass it the name from our file name that we've compiled into this map here, and then just look up the sprite for it. So that'll all be next episode, though, going on 55 minutes. Until next time, keep encountering wild monsters, but don't make them fight. That's just cruel.